Throughput, as we have just seen, is dependent upon factors ranging from network to media to devices. Since we interact with devices and the simulations that we do would also involve devices and their working, in this module, we shall see what is throughput of internet working devices, and we'll take a typical case study from Cisco as an example. A point to be noted here is that the devices are, after all, theoretically speaking, not relevant because we are concerned with engineering approach. But again, the point that we must understand is that there are some real-world vendors and original equipment manufacturers whose equipment and devices are widely available in the market. The device throughput is measured in terms of either packets or any other kind of message representation. Take the example of TCP/IP. TCP/IP involves packets per second representation at the network layer and the application layer protocol data unit per second at the application layer. Similarly, the asynchronous transfer mode, the ATM architecture and ATM protocols use cells in ATM switches. Cell is actually a 53-byte fixed size header and payload. So it means for both of these different kinds of devices, we'd have the sizes which vary from 53 bytes, 64 bytes, and to the maximum transmission unit, which is the maximum unit that a network can allow to traverse from one link, from one LAN card to the other LAN card, or from one switching device to the other. Let's take the example of Cisco. If we create a topology or think about a scenario in which we have the traffic generator and traffic consumer, these two are connected to each other in tandem. So when the sender starts generating packets and the receiver starts to receive packets, the packet count is done at the output interface and at the input interface. If we were to measure the packets of smaller size, then of course more packets would be generated. And if the packet size is large, less number of packets would be generated. So the packet count along with the length of the packet together forms an important throughput parameter. For example, Cisco claims that it has a device called Cisco Catalyst 6500 switch that offers up to 400 million packets per second, which is in reality the capacity. The throughput is something which is dependent upon how their switch is going to perform when it is deployed. This table actually shows different packets and packet sizes along with the number of packets which can be sent on the Cisco 6500 Catalyst switch on 100 megabits Ethernet and on 1 gigabits Ethernet.